Hey everybody, welcome back to the shop. Today I'm going to show you how to install the LED lighting that is in the ratrig and how I installed this 400 watt chamber heater. All these STLs will be linked down below. You can download them for free. But if you enjoy the designs, feel free to leave me a coffee. The links will be down below. So first thing I want to do is test out how good the enclosure is with just the stock heated bed. We have a 1000 watt AC heater inside and I'm going to heat it up, watch what the maximum temperature is going to be and how long that will take. So I'm going to start the testing at 12:30 and I will circle back when the temperature is hot. And as we can see, we are just shy of 60 degrees. I'm using the temperature of the beacon coil or the tool headboard, the EBB42, which is going to be pretty accurate on what the inside temperatures are going to be. But you don't have to believe me. Here is a thermal probe that has been run into the chamber. We can see 58 to 59 degrees. So I would say the results are pretty nice. I can see that we are at 200 millimeters of build height with a bed temperature of 110 degrees and we are already able to hit the almost 60 degrees Celsius, and it took around 45 minutes. We are now way over an hour and it seems to be stable. The nozzle we are going to use today is this 0.6 tungsten carbide nozzle, which is a cooperation between Fetus and Triangle Lab. So pretty nifty nozzle. So right here in the tip is the carbide piece and then the rest is some kind of a copper which has been coated on the outside. This will provide us with the abrasive resistance which we are going to need for the following filament. The filament that we are going to use today is going to be the fiber heart from Tech, which is going to be a black ABS filled with glass fibers. I already did some prototyping and right here is going to be the part that we are going to print in ABS GF. This is just a PLA print. This wouldn't survive 15 minutes in the heat that we are putting out. So this design is inspired by all the ones I have seen from the Voron series, which has these shadings over here so the light is not shining in your eyes when you're watching from the outside. The strip is just sliding in like you can see, and the double-sided tape will just stick the LED right on here. This is made to use with the T-slot profile. You just use a T-slot and it will mount on the printer. We are going to print 3 of these. I want to use 3 LEDs. I have tried one and it is a little bit on the soft side. So I think if we are going to use 3 of these, then the lighting will be absolutely perfect. So this design is going to be available for you to download. The link will be down below. This will also only work on the 400 or bigger ratrigs. It is the next day and the final part for the lighting has been printed. So we already have 2 of these diffusers for the LED strips. Here is the final part which we are going to need to finish up the lighting. Alright, so let me do the final cleanup and then we can install the LEDs. And here we have it, the final diffuser. I have to say the quality is just absolutely amazing. Printed on the ratrig using the ABS GF from Tech. I got the ratrig back out of its cage because we are going to do some new wiring. Right here in the corner we already mounted the webcam. I made a little bracket for it. This is some cheap generic USB webcam. I ran the cabling just here on the side, then covering it with this stuff right over here. This is some T-slot filler, I think. Not sure what it is, but I will link it down below. Right now I want to pull some cables through the rails. We are going to use the 2 colors. This is going to be the negative, this is going to be for the positive wire. We also got some nice fancy sheeting and something new I have never done before, except for building this printer, is going to be using connectors for all my things. Normally I would put an LED in here, solder some wires on it, directly wiring it to the system and call it a day. This time, however, I want to use connectors because you never know, we have to do replacement and I want this printer to be as easy as possible. That being said, I just reflashed the image on the SD card. Something got corrupted on the last print. We lost the complete webcam interface. Not only that, we also sporadically started to lose the connection with Moonraker. Not sure what the hell I did wrong. I reflashed everything. Everything is now working back again. That's why we are 1 day later. Alright, time to pull some cables, put some connectors on here, and then putting some LEDs in the ratrig. time to give you a little update. As you can see, the LED bars are in. Also over here, all the LED bars are in, just like this side. And we did the extension cables. This one is running up top into this groove. Then we seal it off with a strip. The other one comes out here, and then this one meets together with this one on top. It is meeting right over here, meeting up together over here, which is going to be the extension cord for this light. And then we sleeve it like that, and this is going to be the cabling. Now I'm going to put this on a Wago. Then we are going to install it in this header, which is going to be programmed to control the LED with a PWM signal. So these are the old style Wagos. These days the Wagos are made of polycarbonate, but because we have the room right over here, I will use up my old ones. So this is the dashboard of RatOS. You have to go to Machine, then you go to printer.cfg, and then you scroll down. I have put in my input shaper on line 126, and then on 132 you will have to add LED, caselight, white pin, cycle time and initial white. I will put the code in the description. You will have to copy it here, save and restart, and then the code should be in your printer. Then back on the dashboard you will see on miscellaneous there will be an added tab caselight. It is now at 10%, and if we raise it, you can see the light is getting brighter. If we dim it, the light is off. So now you can play around with the PWM setting. To give you a few demonstrations, first let's start at 0, no lights. Then I'm going to set 10, 50, and 100%. As you can see, everything is now nice and bright and shining in my eyes. I'm pretty happy, it looks neat. Now, only thing that bothers me is that right here in the corners, these LEDs are not lighting up because there are no LEDs present. But I think I have a solution for that. Now, I think it would be a shame to not light up the corners, so I'm going to use leftover strips. I have more than half a spool left. I'm going to cut them up, put some leaves on it. I'm going to prop them up right over here and basically do the same thing as the ones we made for ourselves. So I'm going to skip forward until these light up, and then the ratrig can go back to its home. Alright, we have done all the wiring. Time to put on some lighting on the logo. And there we go, we can see in the four corners. Now we have the ratrig logo turning on. We can also turn it off. Pretty cool. We now have the lights of the ratrig logo. We also have the lights of the build chamber itself. And let's have a look at the back how I have done it. This is one of the lights. It is running down all the way to the bottom. Right here we have a connection point. I couldn't be bothered to do something more special than that. So yeah, here's the connection point. Then the wiring is running underneath this corner all the way up to here, where we are doing the same thing. Couldn't be bothered. There are some Wagos over here running all the way up to this light and also to this light, getting back under this profile all the way to there, up, and then it goes into the control box right over there. This is the extra wire running through the sides all the way to the second port, and the second port is also programmed as an LED. Back at the printer.cfg right over here we have the chamber lights, and then we copied the same line, called it the ratrig logo, and then we just put in the other port, which is going to be PA3. There we have it, the rat is back home. Time to turn on the lights. That put the inside lights at 100%. Have to say, wow, super clear. Now let's put on the ratrig logos. I'm going to put that at 100%, and this is what it always should have been looking from the start. The LEDs are done, we can finally see what we are printing. Now it's time for the next thing. Then it's time for the last thing, and that is going to be the heating solution. For that we need a power supply. We also have a controller, which is also old nostalgia. This is also from the first enclosure I ever built, which was standing right over there, so we are going to reuse that. Then I also did a bunch of designing. I ended up making this design. This houses two heated elements. Like you can see, these are both 200 watts for the total heating capacity of 400 watts, together with this blower, which is going to sit up right up there. This is going to be one hell of a heating solution. Now it's probably overbuilt. I'm pretty sure it is over-designed, but hey, I had a lot of fun building it, and this is going to be the next part, printing the heated assembly. All the printing is done. The ratrig did an amazing job with the Ceratec ABS-GF. On my right, your left is going to be the final prototype, fully printed in ABS. Right on my left, your right is going to be all the prototypes we have done along the way. We can see that we needed about 3 iterations before we got to the final product. So we wasted around 2 kilograms to get to this 500 gram prototype. The only thing I'm going to do right now is make a little test setup to see if everything holds up. These are going to be our 200 watt heater cores. We will have one over here and one over here. Something neat I have added is going to be these spoil parts, and this is going to isolate the heaters from the printed parts. So in the case that this is not handling the heat quite enough, I can reprint them in a higher temp filament like PPS or a nylon, and these are hugging the heater like this. And this is what it should look like. We can see it is nicely clamped on both sides. There is a little bit of a cable guide right over here to run some wiring. And this right here is the entrance of the fan. It will run straight through. This is the test setup. We have the 2 heaters inside. We have our fan, PSU, we have our power, and right over here off screen we have something to monitor everything that is going from this to this. First, let's turn it on. Just like that. Already getting nice and warm. I have to say it is working really good. Already getting nice and warm. We get a nice airflow. It is actually working a little bit too good. We are now pulling 535 watts through this power supply. This is only a 20 amp power supply. So this thing is probably right now. Yeah, so we need a second power supply. This isn't cutting it. It is dangerously overspec. The wires are too thin. The heaters inside are pulling way over 200 watts. They are actually pulling 250 watts per heater. I bought heaters that were 200 watts, so we are 100 watt over spec, which means we are 4 amp over the target we were aiming for. I was aiming to be around 20 amps, while we are way too high. So the gauge of the wires is too thin. The power supply is not strong enough, and probably I will need to do some redesigning to get more space for thicker wires. Ouch. All right. So let me order some parts and I will get back when everything is ready. Now, previously I stated that this is going to be a 500 plus watt heating system. Now I measured on the wrong side. I measured before it entered the power supply, not accounting for power losses. These Chinese imports are mostly 80% efficient, and I think while I'm pushing it at the maximum power output, which I think is 440 watts. So I did the next best thing. I sacrificed this power meter because this is only rated for 10 amps. Well, this thing is gonna blow. But we should see some power ratings before we blow the fuse. So yeah, let's try that. I'm going to power on the socket. And I could see it spike over 10 amps and even complain to me. So yeah, it really looks like the heater is also way over spec than they promised. It is not a 200 watt heater, looking more like a 240 watts, which makes a total power of 480 watts. The fan is about 7 watts, but the power output of the power supply was even 100 watts more, which means that we are dealing with a massive amount of inefficiencies. So the power supply is not cutting it, the heaters are over spec, so I'm really happy I did the good job by putting on bigger cables. I have done some redesigns for the final design. You will be able to use 2.5mm square cables for the heaters. The heaters themselves are only 1mm square, so I'm not too worried about heating them up. I'm using XT60 connectors right here on the power side of the heaters, and then we have your regular fan connectors for the fan itself. So it is super easy to remove out of the chamber, which is what I want. But now I have to look for, what I'm going to do with the power supply. I've been thinking about buying 2 of these cheap power supplies, putting them next together using some diodes and hope they are doing some load sharing. Or I could spend about the same amount of money for the better power supplies, because it's still half the price of a meanwhile. I think the bigger one that is more trustworthy is going to be 75 euros. These are only around 26 euros for 600 watts. What would be the best content? Probably 2 power supplies in parallel, right? But maybe that's something for another video. I'm going to order the power supply that I trust the most. So we mounted everything on this relay. We have a double input because this relay is only capable of 16 amp for each channel. We need the both channels, so we secured it with 2 fuses of 15 amp, so we get total power input of 30 amp. And if one of these inputs for some reason, because of a loose connection or because the relay is failing, then the fuse should pop and the circuit is back to safe again. The only thing we need to do is turn on this controller to see if everything works. For that we need power, which is going to be the positive and negative to power this unit. Then we also have 2 purple cables. One is coming from the power supply to this unit and then back to one of these relays, which then goes back to the negative. So we have a circuit that can be interrupted by this thing. Okay, so this thing is now turned on. We have the probe in our hand. The temperature reading right over here is what we can see. When we touch this, you will see it is going up and then it will click out. Just like that. So now it interrupted this relay. There's no more power going to the heater. So one thing I want to let it do is cool off, like it has done right now. Now I'm going to put it in front, the one that is actually working. Now we have to give it a little weight and now it popped. So we now have 29 degrees on the output. So every time this cools down, as you can see, it is now going to cool down back to 25 degrees and then it will re-engage that relay, sending power to my heaters. Everything is mostly finished. The heater is inside, everything is connected, and right here in the bottom is the new power supply, the much stronger one, and we also have a hidden switch. That's why you don't hear anything right now. When I flip the switch, the fan will automatically start running. Also, the heater will automatically turn on. The reason why I did it that way is that for some reason, if anything goes wrong, the fan always keeps spinning without the heaters accidentally just turning on because the SSR is broken or something like that. So the fan will always be on if the switch is flipped. One thing left to do is turn on the switch and see what is going to happen. But maybe first, let's take a closer look on the underside. And then right over here we have our heater. We have our fan sitting on top. This is removable. Then we have our heater core and then we have our cables right here at the bottom. Everything is a quick connect. I will pull one up. So right over here you can see is one connector and there we have the other one. So we can just make everything loose, remove it, because we need to remove that heater if we want to pull out the ratrig. Then we also took some power from the ratrig. Right in that hole right over there is the power running and it is going down into the belly. There are also some quick connects right over there. We used XT60 connectors because I couldn't find any better, but this is how it looks. So that power connector goes down, as you can see, it goes to the power supply, and from there it goes to an SSR. We have 2 Wagos and we have one cable running to the front, which is going to be our controller. Right here on the back we have a switch. If we flip it, we will turn on the power. This is connected to the wire behind the fuse. So everything is fused. The standard fuse of the ratrig is a 15 amp, which means that the whole system can pull way over 3000 watts. It never is going to happen with the standard ratrig. So I mounted this switch and when I flip it, the fan starts spinning, the SSR turns on, and right over here we have our control panel with a temperature reading. Right now the probe is dangling right over here. It just goes down through a hole next to the printer and into the unit. So I just turned off the controller, which turns off the SSR. So right now we only have the fan spinning. So the first thing I want to do is put the door on and do a new test to see how fast we can go to 50C, and then do a new test to see how hot we can get it with the bed and the heater. I'm going to set the heated bed to 110 and then I will turn this to 50 degrees C and see how long it takes. I started the test at 15:14, so it's now a 3:15 and we're going to see how long it's going to take to get this thing up to 50 degrees Celsius. There you go, 50, and it is 15:33, so it's a little over 50 minutes to get the chamber up to 50. It's going to go to 50.5, and then it should turn off that SSR right over there. And here we have it, the last piece of the puzzle, because I want to cover up everything that's down there. I'm going to make a cover plate using some 3D prints and a last piece of wood to make everything nice and neat. Okay, so now I want to do something different. We already know that 50 degrees is not a problem at all. We could even see that without the chamber heater, we could get up to 52 degrees Celsius right over here. Now I'm going to set up the system to get as hot as possible. We are going to do a power measurement because right there on the floor is my smart plug. So we will see everything. It will pull from the wall. And here we have it. We are now pulling a total power of 1691 watts. We are pulling 7 amps at 226 volts. So we are well over 1.5 kilowatts of heat. So this number is with the hot end at 150 degrees Celsius. The bed is on full whack, heating up to the maximum temperatures. And also the heater is on. It is pulling full power. So we are seeing somewhere between 1600 and 1700 watts of heating power. Woof, that's quite a lot. So you Americans on 110 volt, you will need quite a hefty breaker for that. This is probably going to take forever. We are now 13:18, so 2 minutes later, and we will see what we will reach and where we start to struggle with temperature. So the next part is going to be this. I did a little glue up yesterday. So all these boxes were just to put some weight on the glue joints. So we're going to remove all the boxes. By the way, if you're wondering why all these Polymaker boxes, they just sent me a new shipment with a boatload of filaments because we are going to do a lot of PVB smoothing with the Mega Smoother. Now, like you can see, we have a massive gaping hole. We need to fill up the hole. And then we have some LEDs I want to implement. As you can see, we have some nubbins right over here. This is for the wood to have a standoff. We are going to put a little LED strip right over here. And we are obviously going to do the same. We are going to put an LED strip right over here. So the wood is going to sit here and on those steps, and the light will shine over the wood, hopefully giving us a nice visual. Alright, the only thing I need to do is cut a piece of wood, glue it in there, put some LEDs in, and finish up this bloody project. So this is going to be the front. We can see we have some seams. We have 4 seams. This is a 4-piece glue up, and this is pretty ugly. So we are going to fill it up with some ABS putty that we made ourselves. To make this ABS glue, or filler in my case, it is really easy. All your support structure, you throw it in there, then you grab some acetone, you stir it up, and then you get a nice goopy paste. So as you can see, this is my goopy paste, and we are going to apply it on everything that is not looking that pretty. Now the trick is going to be to not put too much on here, because if you do so, the drying times will be prolonged. So just a thin coat, and then just spread it out like this. The layers are already melting. You barely can see that there is a layer line, so you put it on there, you leave it a little bit on there, and then you start to spread it, and then the seam just, almost disappears. Update time, we are almost nearing an hour, and you can see right over there is going to be 57 and a little bit more. This is going to be the consumption right now. We are pendling between 1100 watts and 500 watts. So every time the bed cools down, like it is doing right now, we can see only the heater is active. When the heated bed is engaging, like right now, we are over 1000. So we are probably around the 700-ish watts now, constantly pumping in the chamber. And like you can see, 57.8, it is still climbing ever so slightly, but it is going to take a while. So that means that anything above 60 degrees Celsius chamber seems to be a bit of a stretch. Now, the good thing is, right now it only takes about 20 minutes to heat up the complete enclosure to a sustainable level for ABS printing or better. So I would call that a win. Right now it's 58.1 and still climbing. So yeah, this is taking way too long. I could add a second one on the other side. No. So yeah, let's call it 55 with ease. In 20 minutes, that seems to be perfectly fine for me. I will need to do a lot of testing to see if nylons or any other materials like PPA, for instance, is going to be problematic, but we will see that soon enough. And meanwhile, I have been busy. Let's look at the cover that we are going to put there on the enclosures. we are a few minutes over an hour, and we can see we have actually reached 61 degrees. Let's say that after an hour of heating up, 62 will definitely be possible. It is pretty cold in the shop right now. We are still the middle of winter, and I can already feel that the wood is very nice and insulating. We don't feel a lot of losses in the wood itself. Most of the losses is going to be from this sheet, unfortunately. Now, there is nothing we can do about it except for maybe real gloss. This is going to be the final part of the build, which is going to be the cover plate that we will put underneath. On the other side, we have two LED strips. I have one over here and I have one over here. It is going to provide a little bit of a, it's going to provide a little bit of an ambiance, but mainly it is going to be used to let me know that the fan is still running. So this is just a power indication, really overbuilt probably, but hey, now I know when the fan is running when I turn off my controller. Well, this is not the most important part. I have already did a little dry test and it is going to be really tight, which was not planned. All right, let's put that thing underneath and finish off this complete project. This is going to be probably the last video in a while about the ratrig. We have some other stuff that we need to do. We have some other reviews like the iBus Polyphemus, I think, is one of the last reviews that we are going to do. And then on my right, out of camera, we are going to make some more content about the Mega Smoother, or the Mega Smoothie like somebody else called it. We are going to do some cosplay production. So we are going to make molds, we are going to do some pouring, we are going to make some clothing pieces for some Star Wars costume, and it's all going to be smoothed or used with the Mega Smoother. So something to be excited about is going to be a kit. I hope it's going to be fairly affordable as you need to build it yourself. I am thinking of making these machines on commission. It is probably not going to be cheap if you are going to ask me to build it on commission, but that is something to worry about later. Right now, it's time to finish this beautiful project. Final prints I did on the ratrig Vico 4. This is ABS printed at 30mm cubed. So this is super high speed with a 0.6 nozzle and 0.25 layer height. So yeah, these are the results close up. There's a little bit of inconsistencies, but this is just the filament being pushed at its utmost limit. And just like that, the build is finished. Now, I could turn in 4 screws, I made the holes for it, but like it looks right now, yeah, it is tight enough. Now we have a lot of light leak right here on the bottom. We have a little bit up top. Well, it is just added bonus. Now we have a little bit of light in this bottom cabinet. So this is going to conclude the build of the ratrig enclosure, which is heated. Everything you need from the STLs to the parts that you need to purchase to make this work will be all linked down below. A few of these will be with an affiliate to support the channel. Let me know what you think about the ratrig ultimate enclosure build. I had a lot of fun. And by the way, massive shout out to my members and the viewers of the channel. Without you, I wouldn't be building this stuff, even though more than 5 people watch these videos. All right, that's gonna be it. Now I'm going to take a few rests and then we will continue with the Mega Smoother project and the Polyphemus review. And probably in a few months we will receive the GD box, I think, hopefully, to do the final GD review. So this concludes the end of the ultimate ratrig enclosure. We could see that heating it up to 60 degrees is actually pretty reasonable. 62 if you have the patience. But nonetheless, I'm going to enjoy this little build right over here because very soon I will have a commission job. Again from Mike from MP Customized. He is doing a massive new case build and this thing will come in very handy. Alright, that's gonna be it. Thank you for watching and guys, I see you in the next one.